Introduction to logarithmic functions without graphing. Today we're going to write equivalent forms of exponential and log functions and then write and evaluate log functions. The key thing to know here is the phrase, the exponent that the base b must be raised to get a is x. Let's go through that. The exponent, right here, the exponent is x. Well, in English, we'd say the exponent is x. That means the x is the exponent. In math, the word is always means an equal sign. So in the logarithmic form, you'd say equals x. The exponent equals x. So the exponent's x, it equals an x. Base of b. Well, when you're dealing with exponents, 2 to the power of 3, then the 2 is your base. When you're dealing with logs, then the 2 is your base. So here you have a base and there you have a base. The word base works for both exponential equation and logarithmic equation, where b is your base. Then the easiest way to think about the a, the other thing, is just it's the other thing. Wherever you have a gap, you put the a. So the exponent equals, and then the bases stay bases. Let's take a look at a couple examples, and this will become pretty clear. Here we have 6 to the power of x is equal to 216. First, what is your base? Your base is 6, and your exponent is x. So when we write this down, we're going to say log, and then base is equal to the exponent. And then the other thing that's left over goes in the blank. So we just fill those in. Log base 6 of 216 is equal to x. So if we had to solve this, we would say 6 to what power is equal to 216? And the answer to that would be 6 cubed is equal to 216. That means that log base 6 of 216 is equal to 3. Now the next one, this is a good review of basic vocabulary. Any number raised to the power of 0 is equal to 1. Very nice. Now let's fill in our log. We had a base of 1.2, so we're going to say base 1.2. We have an exponent of 0, so it always equals your exponent, and then the 1 comes right in there. Again, figure out what your base is. Our base is 4. Exponent of -1, and the whole thing is equal to a quarter, 1/4. Remember, 0.25 is the same as 1/4. Why does that matter? Well, I want you to think about this. If you have a negative exponent, 4 to the power of -1 flips that upside down. So that gives you 1/4. If you remember your negative exponents from the previous section, this will go a lot better. So log base 4 of 1/4 is equal to -1. Now we're going to do it the other way around. So the last ones we're putting them into log form. Now we're going to put it into exponential form. So we look at our base. Our base is 2. It's going to equal our exponent. Our exponent is 6. And then the x here will be that other number. So it's going to look like this. We have a base of 2 equals our exponent of 6 is equal to x. Now, if they actually wanted you to solve for x, it would be pretty easy. You'd say, what is 2 to the 6th power? And if you had to solve it, you'd say x is equal to 64. Here we have log base 4.5 to the power of 1 is equal to 0. Base of 4.5, exponent of 0 is equal to 1. And then we just write it into exponential form. So 4.5 to the power of 0 is equal to 1. And that makes sense. Any number to the power of 0 is equal to 1. We have log base pi of pi is equal to 1. Our base is pi, our exponent is 1, and then our other number is still pi. It's going to look like this. Pi to the power of 1 is equal to pi. Now a few of these demonstrate some rules that we have. We know that any number raised to the 0 power is equal to 1. That means if you ever have a 1 inside the log right there, you're always going to have an answer of 0, and vice versa. If you ever have log base of the same number, it's always going to equal 1. These are general rules, and these are the vocabulary that you should know for that. If ever you have a base of the same number, it's always going to equal 1. If ever you have log of a 1, it's always going to equal 0. Why is that true? Well, any number raised to the power of 1 is just that number, and then any number raised to the power of 0 is simply equal to 1. The other thing you need to know is what is a common log. In your calculator, when you click the log button, it will automatically think a base of 10. So you can only use your calculator for log base 10. If there's no base written, we always assume it is a 10. Later on, we'll talk about the change of base formula so that we can use calculators for different bases, but as of now, only use calculator for base 10. Now, sometimes we're going to ask you to evaluate the logs. Well, these aren't base 10, so I can't use the calculator. So what do? We simply finish writing it. They wanted to evaluate or to simplify or to solve. We don't know the answer, so we put an x there. Once we have the x there, we set it up the same way we just did. Put it into exponential form, we have 7 to the power of x is equal to 343. So then you ask yourself, 7 to what power is 343? Well, 7 times 7 is equal to 49, times 7 is equal to 343. So our answer will be x is equal to 3, because 7 cubed is 343. And then just do the same thing for each of these. Set it equal to x, set it equal to x. Now this is a fraction. We have base 3, exponent of x is equal to 1 over 9. Now we went from a whole number to a fraction. That means that our exponent is going to be a negative. So we're going to have 3 to the power of negative, and that's going to flip it upside down. Then 3 to what power is 9? Well, 3 squared is equal to 9. So that's going to give you 1 over 3 squared, and that's 1 over 9. First you take care of the negative exponent, and then you take care of the exponent as a whole. That means x is equal to negative 2. Set up the next one the same way. So 1/2 raised to the power of x is equal to 1/4. Sometimes it's just plain easier to see these if you put them into fraction form. 1/2 is the same as 0.5 to the power of x is equal to 1/4. Well, 2 squared is 4. So I know that 1/2 squared is going to be 1/4. So that gives me an answer of x is equal to 2. So when you have to evaluate these by hand, you simply set it up in exponential form, use a little bit of common sense, and you usually get the answer right. Now, if they tell you to solve for x or to solve these, then you set it up the same way. You put it in a format that makes sense to you. Here I have log base x. I don't know what the base is. I know that the base is x though, and that the exponent will be 2, and the other number is 9 over 64. So we set it up in regular exponential format and then solve. Well, what's the opposite of squaring? I know the opposite of squaring is taking the square root. Whatever I do to one side, I do to the other. That gives me x is equal to, the square root of 9 is 3, the square root of 64 is 8. X is equal to 3 over 8. Right, this one they put the x in the front. It doesn't matter if the x is in the front or the x in the back. It means basically the same thing. If you don't like the way this looks, then you simply scribble that out and you say equals x on the back side. It doesn't really matter. Then you set it up like normal. 2 to the power of x is equal to the cubed root of 2. Now here, it would be much easier if you remembered our fractional exponent. What is another way of writing the cubed root? The cubed root can also be written as a fractional exponent of 1/3. So if I was to rewrite our problem, I'd have 2 to the power of x is equal to 2 to the power of 1/3. Well, what is x supposed to be? X is supposed to be 1/3. Just that simple. Again, solve the equation, so we switch it to exponential form. So x to the power of negative 4 is equal to 256. Well, first off, the negative exponent means we're going to be flipping something upside down. So we know whatever x is going to be a fraction. Then we'd say, what is the 4th root of 256? The fourth root of 256 is 4, because 256 breaks up into 16 times 16, and that breaks up into 4 times 4. So the fourth root of 256 is 4. But we have a negative exponent. So that means our x is going to equal 1 over 4. Because 1 over 4 to the power of negative 4 gives you 4 to the power of 4, which is equal to 256. And by using this common sense, we can figure out that x is equal to 1/4. Set this one up the same way we've been doing it. 2 to what power is equal to the fourth root of 8? Well, I'm going to take that 8 and say 8 is the same thing as 2 times 2 times 2. Well, 2 times 2 times 2 is the same thing as saying 2 cubed. So I'm going to rewrite that. 2 to the power of x is the same thing as the fourth root of 2 cubed. And now we're going to use our fractional exponents. 2 to the power of x is the same thing as 2. And if I'm using my fractional exponents, I know that the fourth root of 2 cubed is the same thing as saying 2 to the 3/4. That means my x is going to equal 3/4. If you don't remember your fractional exponents, you need to go back and review them. Here's one that looks a lot more complicated than it actually is. So again, we're going to take it out of log form and put it into exponential form. Remember, we always use parentheses when we have the binomial like that. Now, they were nice. We were lucky. We said x plus 12 to the power of 1. Well, I don't need to do anything. They could give you a square or a cube and you'd have a whole bunch of multiplying to do. But here, x plus 12 to the power of 1 is simply x plus 12. And that still is equal to 15. Subtract the 12 to the other side, and x is equal to. Looks a lot more complicated than it actually is. Next, inverses. To find an inverse, it doesn't matter if you're working with logs or anything else. To find the inverse, you always do the same thing. You switch the x and the y, and then solve for y. Doesn't matter what we're talking about, it's always the same thing. So here, we have y is equal to log x plus 9. First off, what is your base on this? Remember, you have no base written, so your base is 10. But we'll get back to that in a second. First thing they want us to do is switch the x and the y. So here is the y and the x. We're going to switch those. Now we have x is equal to log of y plus 9. Notice I simply switched the x and the y. I didn't do any math, I just rewrote them. Now we go back and solve for y. Now in order to solve for y, we're going to put it into exponential form, which is where that base comes in. We have a base of 10. That gives us 10 to the power of x is equal to y plus 9. Now, I'm not solving for x. Remember, I'm solving for y. So all I need to do is get the y by itself, so I subtract 9 to the other side. 9's cancel out, and that gives me y is equal to 10 to the power of x minus 9. Now, this is written backwards, so just to make it look nice, we'll rewrite it. Y is equal to 10 to the power of x minus 9. First thing we're going to do is switch the x and the y. So I have y is equal to log base 10 of 10x. I'm going to switch those, and that's going to give me x is now equal to log 10 of 10y. Remember, we're not solving for x, we need to solve for y. In order to do that, I'm going to put it into exponential form. That gives me a base of 10. An exponent of x is equal to 10y. Now, in order to get the 10 away from the y, the opposite of multiplying is dividing. So we divide both sides by 10. That cancels out, and you're left with y is equal to 10 to the power of x over 10. Now, you cannot cancel out those 10s because you don't know what the x is. So that gives you y is equal to 10 to the power of x over 10. Switch the x and the y. Then solve for y. First, put it into exponential form. Then we can divide both sides by 4. gives us y is equal to 2 to the power of x over 4. And again, we don't know what the power of x is, so these are not like terms and they cannot be canceled as is. Don't forget to go back and review your negative and your fractional exponents if you need to.